In our final part of section 6.1, part 5 that is, we're going to take a look at shading when we have a set of three sets within the Venn diagram. So the next example says, for each of the following, shade the portion of the Venn diagram that illustrates the set. This time we're going to do A intersect B intersect C. Again, both of these symbols mean intersect. But now I need three sets. So when I orient three sets inside that Venn diagram, I tend to do two sets on the top and then the last set on the bottom of it. It does not really matter. You can do it either way, put the two sets down below, one above, but I'll do the two sets up top. No reason, just because that's the way I learned it. Okay, so we need the region or regions that satisfy this statement. So we're looking where A intersect B is. Well, that would be this one and this one. But we're also taking B and intersecting it with C. Well, that would be this one and this one. So the intersection of A and B and C would be this region in here. So we're going to shade this little strange looking region inside of there. And that's our final answer. So this is not part of the final answer, and neither is that one. There's the intersection of all three sets. Part B asks us for C intersect A union B. For the first time, we're seeing a set of parentheses, which does imply an order. So we're going to come in and do C union B first. Then we'll take that answer and intersect it with A. There's A, there's B, there's C. So A union B would be this region, this region, this region, this region, this region, and this region. So everything that's inside of A and B makes up this. So those checks are that. Okay, now I'm going to come in and I'm hoping the blue shows up here. We'll go back to using colors again. We're going to come in and check off the regions that represent C. What we knew is C is this one, this one, this one, and this one. So C is in blue. And now we're going to intersect. And the intersect means that I need where the check marks are both sets. So I need something that has both a blue check and a black check inside of it. And we can see where the blue and the black is this one, this one, and this one. So when I'm done, I'm going to shade this region, and this region. And there it is. So there's the shading that represents C intersect the A union B. Our next example, we're going to take a look at or try and identify A union B complement. And we're going to intersect that with C. So slightly different. We got a B complement sitting there. So let's go find B complement first. We know that B complement is everything outside of B, which are those four regions. A is made up of this region, and this region. And because we're looking for the union again, we'll just leave everything checked for now. So the union means everything that's got a check mark at this point. Okay, well, now we're going to come in and do the same thing. We're going to intersect that with C. So we'll mark off C, and I'm going to do it with a blue check. So C is this region, this region, this region, and this region. Because we're looking for the intersection, we need things that are checked both with a black mark and a blue mark. And that's just because that's what intersection means. It means what they have in common. So they have in common this region and this region. And that's your final answer. We're not going to shade this one this time because we're picking up B complement. So, okay, comments or questions? I'm hoping that's going well for you. One more. So part D on this one says we need B intersect C complement intersected with A. So B intersect C complement intersected with A. C, and don't forget to mark the universe. Okay, so when I'm doing this one, I'm going to come in and I guess let's do each of the sets in a different color. So let's go check off B first. I'm going to do it in black. So here's B. It's those four, sorry. C complement is everything outside of C. I'm going to do that in blue. So this is outside, this is outside, this is outside, and so is this one. That's in blue. And then I'm going to pick up red, which really is hard to see, but it's red. We're going to do A complement. So I'm sorry, just A. A is this region, this region, this region, and this region. So I checked off each of them. Because again, we're looking for that intersection, we're going to pick up the region that has a check for everything in terms of color. So I need the regions that have a black check, a blue check, and a red check, and that's because of the intersection. So the only region that has all three of those is this guy right here. So we're going to shade in that region, and that's going to be our final answer. Now, if we were looking for the union, then we would finally shade everything that has a check in it, right? But because we're looking for the intersection, we need that overlap. We're looking for where they overlap. So there it is. Okay, on the back of the handout, what you're going to see are some other notations and some theorems. We'll use these when we hit the probability, and at that point in time, we'll definitely write them on the board. But for now, you're going to see set complementation. It talks about if U is the universal set and A is a subset of U, then U complement is the empty set. The empty set complemented the universe. A complement complemented is A, and that's kind of like a double negative making a positive. And it also says that A union A complement is the universe, and that should make some sense. So if I look at A and I union it with outside of A, I'm going to end up with everything in the set. That's the universe. And then A intersect A complement is empty. They take A and intersect it with what's outside of A. They don't have any overlap, and it's empty. There's also the commutative law for union, the commutative law for intersection, the associative law for union, and the associative law for intersection. Those are basically telling you that you can take the unions and the intersection in any order. There's also a distributive law. That is the one that we'll use in the future. And then finally, De Morgan's law, which simply says that if you have A union B complement, that's actually the same thing as A complement intersected with B complement. So when we talk about complements, we go from a union to an individual intersection. And also the same thing is true on the flip side. If we do A intersect B complement, that's actually A complement union with B complement. So let's just take a quick look at one of them. If I intersect A and B, I get these two regions. And if I complement that, I get everything outside of those two regions. Well, A complement would be everything outside of A, but we're going to union that with everything outside of B. And sure enough, we get everything outside of these two. So they do make some sense when you take them and break them down. And that wraps up section 6.1 for us. On to section 6.2 next.